In this lecture, we are going to solve these two questions. So let's start with the first one. After all students have left the classroom, a statistics professor notices that 4 copies of the text were left under desk. At the beginning of the next lecture, the professor distributes the 4 books in a completely random fashion to each of the 4 students who claim to have left books. One possible outcome is that one receives second's book, 2 receives fourth's book, 3 receives his or her own book, and 4 receives one's book. This outcome can be abbreviated as 2431. And in part A, we have to list the other 23 possible outcomes. So in this case, the total number of outcomes that we have are 24. It is 24 because it's equal to 4 factorial. Okay, and one outcome has already been listed here, and we have to list the other 23 possible outcomes. So one possible outcome could be 1, 2, 3, 4, right? So this means that 1 receives his book, 2 receives his book, 3 receives his book, and 4 receives his book. And another possible outcome could be 1, 2, 4, 3. So this means 1 receives his book, 2 receives his book, 3 receives 4's book, and 4 receives 3's book. Another possible outcome could be 1, 3, 2, 4. So this means 1 receives his book, 2 receives 3's book, 3 receives 2's book, and 4 receives his book. So let me pause the video and write all the other possible outcomes that we could have in this case. So these are the 24 possible outcomes that we could have. I've also written the 2, 4, 3, 1 here. Okay, so these are the total number of outcomes. Now let's move to part B. Let X denote the number of students who receive their own book. Determine the probability mass function of X. So we know that the maximum value that X can take is 4, and the possible X values are 0, 1, 2, 3, 4. So we know that the possible values that X can take are 0, 1, 2, 3, and 4. And to complete the probability mass function of X, we have to find these probabilities. To find these probabilities, let's list down all the possible outcomes and let's find the X value associated with those outcomes. So as you can see, I have listed all the possible outcomes here. And now let's write the value of X associated with these outcomes. So in this outcome, 1 receives his book, 2 receives his book, 3 receives his book, and 4 receives his book. So in this case, the value of X is 4 because it is the number of students who receive their own book, and in this outcome, everyone receives their own book. In next outcome, 1 receives his own book, 2 receives his own book, and the books of 3 and 4 gets exchanged. So in this case, the value of X is. Similarly, in this case, the books of 2 and 3 gets exchanged and 1 and 4 receive their own book. So even in this case, the value of X is 2. In this case, only 1 receives his book and 2, 3 and 4 don't receive their own book. So in this case, the value of X is 1. And similarly, we can find all the other values of X associated with these outcomes. So let me pause the video and write all these values for you. So these are the possible values of X associated with these outcomes. So as you can see, the maximum value that X is taking is 4. Now let's complete the probability mass function of X using this information. So let's write X here, and this is probability of X, and the possible values that X can take are 0, 1, 2, 3, and 4. Now what is the probability that value of X is equal to 0? So let's see. So X value of X is 0 here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means there are 9 possible outcomes associated with this value of X, and we know that all these outcomes are equally likely as the professor has distributed the books randomly. So the probability of getting each outcome is 1 by 24, And in this case, because there are 9 outcomes associated with this value of x, so that means the probability is 9 by 24. Okay, similarly, we can find the probability that x is equal to 1. So let's count the number of times 1 is appearing. It's 1, 2, 3, 4, 5, 6, 7 and 8. So 1 is appearing 8 times. So the probability that x is equal to 1 is 8 by 24. Now to find the probability that x is equal to 2, let's count the number of times 2 is appearing. So it's appearing 1, 2, 3, 4, 5, 6 times. So this is equal to 6 by 24. Let's count the number of times 3 is appearing. Well, 3 is not appearing in this table. So the probability that x is equal to 3 is 0 by 24. And let's see the number of times 4 is appearing. 4 is appearing only once. This is the outcome. So the probability is 1 by 24. And that's it. This is the probability mass function of x. Now let's move to our second question. 3 couples and 2 single individuals have been invited to an investment seminar and have agreed to attend. Suppose the probability that any particular couple or individual arrives late is 0.4. A couple will arrive together in the same vehicle, so either both people will be on time or else both will arrive late. Assume that different couples and individuals are on time or late independently of one another. Let x is equal to the number of people who arrive late for the seminar. In part A, we have to determine the probability mass function of x. So a lot of information is given in this question. So let's first write all the information that has been given. So we are given that the probability of late arrival of a couple or an individual is 0.4. So probability of late arrival, so I'm using L here, is equal to 0.4. And so this means that the probability of arrival on time, so its probability of arrival on time is 1 minus 0.4. So this is equal to 0.6. So L is for late and T is for arrival on time. So these are the notations that I am using. Now x denotes the number of people who arrive late for the seminar. Well, in this case, what is the maximum value that x can take? So what we can do is we can consider one couple as an individual because either both will be on time or else both will arrive late. Taking things in this way, the number of people, the total number of people that we have is equal to 5. So total number of people is equal to 5. This is because we have 2 individuals and 3 couples, and we are considering 3 couples as 3 individuals. So that means the maximum value that x can take is equal to 5. And that would happen when everyone arrives late for the seminar. So how many outcomes are possible here? Well, as there are 5 people and each individual can have 2 outcomes. Either he comes on time or late. So the total number of outcomes in this case, so total number of outcomes is equal to 2 raised to the power 5, and this is equal to 32. So these are the total number of possible outcomes. And let's define an outcome like this. So let's say that 1, 2, 3, 4 and 5 L is one outcome. So this means that first 4 individuals come on time, but the 5th individual arrives late. Similarly, another possible outcome could be 1, 2, 3, 4 L and 5. So this means that the first 3 individuals and the 5th individual comes on time and the 4th individual is late. So like this, we can have 32 outcomes. So let me list down all the possible outcomes for you. And then using those outcomes, we can find the probability mass function of X. So let me pause the video and list down all the possible outcomes. So I've written down all the 32 possible outcomes here. So this 1, 2, 3, 4, 5 means no one is late. 1, 2, 3, 4, 5L means only the fifth individual is late and the first four are on time. 1, 2, 3, 4L, 5 means first three are on time, fifth is on time, and fourth one is late. And similarly, you can interpret the rest of the outcomes that I have written here. Just to show you one more example. So here we have 1L, 2, 3L, 4L, 5L. So this means that the second individual is on time and the first, third, fourth, and fifth individual are late. So now let's write the X value associated with all these outcomes. In this case, no one is late, so X equal to 0. In this case, X is 1 as one individual is late. In this case, X is 1. 1 here as well. 1, 1. Here 2 individuals are late, so X is 2. Here also X is equal to 2 and here also. Here 3 individuals are late, so X is equal to 3 here. So these are the all possible outcomes and the X values associated with them. Now let's find the probability mass function of X. So we can see from here that X can take values 0, 1, 2, 3, 4 and 5. Now let's calculate the probability that X is equal to 0. So probability that X is equal to 0. We can see that the X is equal to 0 is associated with only this outcome. So that means the probability that X is equal to 0 is equal to the probability that we will get this outcome. So this is equal to probability of getting the outcome 1, 2, 3, 4 and 5. Now an important point to note here is that this probability is not equal to 1 by 32 because all these outcomes are not equally likely. So what is the probability that we will get this outcome? Now because these events are independent, it is given to us in the question. So it's given here that different couples or individuals are on time or late independently of one another. So this means that this probability is equal to the probability that one will arrive on time multiplied by the probability that two will arrive on time multiplied by the probability that 3 will arrive on time multiplied by the probability that fourth individual will arrive on time and multiplied by the probability that fifth individual will arrive on time. And we are given in the question that the probability that an individual will arrive late is 0.4. So the probability that individual will arrive on time is 0.6. So this is equal to 0.6 raised to the power 5. So this is the probability that X is equal to 0. And this is equal to 0.0778. Now let's find the probability that X is equal to 1. So let's see what all outcomes are associated with this value of X. So we have 5 outcomes that are associated with this value of X. So the probability that value of X will be equal to 1 is the probability that we will get all these outcomes. So you can write here that it is the probability and you can write all those 5 outcomes here, right? So it will be equal to probability of the first outcome, which is equal to 1, 2, 3, 4, 5L plus the probability of the second outcome, which is 1, 2, 3, 4L comma 5 and plus the probability of all the other 3 outcomes. So once again, as we know that these events are independent, so the probability that these 4 individuals are on time is 0.6 and as these are 4, so it is equal to 0.6 raised to the power 4 multiplied by 0.4 because one individual is late. Similarly, even for this, we have the probability 0.6 raised to the power 4 multiplied by 0.4 and we have the similar property like this probability for all the other 3 outcomes. So this means this is equal to 5 times of 0.6 raised to the power 4 and 0.4. So this is the probability that X is equal to 1 And once you solve this, you will get 0.2592. Let's find the probability that x is equal to 2. So let's see what all outcomes are associated with that. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 outcomes associated with this value of x. So that means probability that x is equal to 2 is equal to the probability of all these outcomes. So it will be equal to the probability of outcome 1, 2, 3, 4L, 5L plus the other outcomes, the other 9 outcomes. So there are 3 individuals who arrive on time, so it is equal to 0.6 raised to the power 3 and 0.4 raised to the power 2 because there are 2 individuals who come late, and plus this same expression 9 times more. Okay, because the probability for all the other 9 outcomes is also this 0.6 raised to the power 3 multiplied by 0.4 raised to the power 2. So that means this is equal to 10 times 0.6 raised to the power 3, 0.4 raised to the power 2, and this is equal to 0.3456. So I hope you have now understood that how to calculate the probabilities using this information. Similarly, you can calculate the probability that x is equal to 3 and the probability that x is equal to 4 and the probability that x is equal to 5. For example, the probability that x is equal to 5 is associated with this outcome. So the probability that x is equal to 5 is the probability that we will get the outcome 1L, 2L, 3L, 4L and 5L. So that means all are late. So in this case, the probability will be equal to 0.4 raised to the power 5. Okay, so similarly, you can find the probabilities when x is equal to 3 and x is equal to 4 using this table. So let me now write all these values of x that we have found in a neat manner. So this is the probability mass function of x. So with this, we are done with part A. Let's move to part B. In part B, we have to obtain the cumulative distribution function of x. And then we have to use that function to calculate this probability. So let's write f of x here. And let's write the cumulative distribution function now. So we are given that the value of x starts from 0. So this is the minimum value that x takes. So if x is less than 0, that means the probability is going to be 0. Okay. So if x is less than 0, then the probability is 0. If x is between 0 and 1 with an equal to sign here, then the cumulative probability is 0.0778. And if x is between 1 and 2, then the cumulative probability is 0.0778 plus 0.2592. So this is equal to 0.337. And if x is greater than equal to 2 and less than 3, then the cumulative probability is equal to the sum of these three values, 0.0778 plus 0.2592 plus 0.3456. So this is equal to 0.6826. And if x is greater than equal to 3 and less than 4, then the probability is 0.913. If x is between 4 and 5, I mean it's greater than equal to 4 but less than 5, then the probability is the sum of these 5 probabilities. So the sum of these 5 probabilities is this, and this is equal to 0.9898. And finally, if x is greater than equal to 5, then the probability is 1, because in that case it is the sum of all these 6 probabilities. Okay, so this is our cumulative distribution function of x. And now using this cumulative distribution function, we have to calculate the probability that x is greater than equal to 2 and less than equal to 6. Well, for this we have a formula. So the formula is this: probability that x is greater than equal to a and less than equal to b is equal to f of b minus f of a minus 1. So in this case, we have to calculate the probability that x is between 2 and 6 with equal to signs. So in this case, it is equal to f of 6 minus f of 2 minus 1. So this is equal to f of 6 minus f of 1. From this table we know that f of 6 is equal to 1 because it is here, and f of 1 is here because x is equal to 1 here. So f of 1 is 0.337. So it is equal to 0.337, and this is equal to 0.663, and this is your answer.